Hi, welcome to Dynamic Canon, and my name is Sagar Suman. Today, let's explore the optimized 3D packing containerization feature, which is in production preview right now. So I will explain you what this feature is about, what's the domain, and stuff like that. So, quick intro. So far, there were a lot of issues with the existing packing strategy when you were using automatic containerization. And what that meant was that if there is a tube which has a volume of, let's say, 100, and this box has a volume of 100, Dynamics till now used to suggest, yes, you can pack the tube in this box because the volume and the weight calculations allow for it, right? But the reality, the geometry, the real world is completely different. Uh, it's not possible to pack a tube with a volume of 100 into this box, which has a volume of, let's say, 100. A very simple example just to break the ice. Now, what this was creating a situation where a system in the legacy was only checking the volume and the weight, as I said, and it was making impossible pack suggestions. Clients have so many SKUs, so many types of boxes, so many types of item dimensions. The impossible pack suggestions was a lot of issue corrupting the containers, the suggestion, the freight rating, the labels, everything what happens after containerization went for a toss, right? So you would have noticed not many clients or projects were using automatic containerization for a very simple reason. It was not there, to be very honest. And with this new feature now, I think Microsoft is taking to the next level where now they're not simply going to look at the volume and the weight. They are going to also look at the XYZ coordinates of the item and the box, and then the 3D packing algorithm is going to make sure all the boxes fit in the box. So what I mean is item fix in the box, right? So I will explain this feature which Microsoft has rolled out with an example, a nice example. But I've also noticed that there are a lot of issues. It still looks like not fully perfect, which will be the series 2 of this video. So in this video, I'll keep a happy scenario just to break the ice so that you understand why 3D packing optimization is such a big addition from Microsoft. In the series 2 video, I will show you all the issues which I've noticed, I may be wrong, which will be improved by the Microsoft once it is available generally, or it could be something is wrong in my testing scenario. Okay, now let's look at a scenario where we have an item, let's say, which has a dimension of 20 in height, 12 in width, and 10 in depth. And we have a large box of 20 by 20 by 20, and we need to do a sales of three of these item, right? So the old legacy solution, what it will do, it will say, yes, you can pack three of these items in this box. Why? Because the box has a volume of 8,000 and three of these slabs would reach to 7,200. So Dynamics will say 7,200 is less than 8,000, so come in. So let me show you what used to happen in the old one. So the packing will go like this, 1, 2. The third box physically cannot be packed in because once the first box is in, this side has taken a dimension of 12. The box is 20, so the only 8 is left over here. And all the dimensions of this item are greater than 8. So there's no way this third item is coming inside this box. And that is exactly what Dynamics was telling the packers and the pickers. You need to pack three of these in one box. And you can understand the chaos it creates in the pack stations, right? The legacy verdict is one box, three pieces because the algorithm was quite naive and was only looking at the volumetric and the weight related stuff. Now the improvements, what Microsoft has done is immense. Now it is partly looking at not only the volume and the weight, but also matching the XYZ coordinates of the item to the box coordinates to see if they fit in. So now if you see the scenario, when the packing algorithm will pack, it will pack the first two and it will realize that third one does not fit in. So the suggestion will be you need to pack these three items into two boxes, which is exactly what we want system to suggest. And this is the exact improvement we were waiting for, a very welcome feature in Dynamics. And I think this will start the use of auto containerization in a lot of projects. It's such a nice feature. I think it was, in my experience and my limited experience, was always falling short because of the issues we have seen earlier. Because even let's say one or two or three or 10% or 5% of wrong suggestions is enough to uh, let the client decide that there's no point using auto containerization, because the impact it creates is significant, the rework and the confusion and the chaos, right? So it's a happy addition. And now I will take you to the system with the exact same item, same box. I will show you the setups and how it is done in Dynamics. So now we are in Dynamics. Let's take a look at the setups, what we need to do. So I'll go to warehouse management, container types. I have created the containers in which we'll do the packing. So I've added the dimensions, 20 each on all the three axes and a volume of 8,000. Then we need to look at the container group. I've created a group with all the three boxes and the container utilization percentage, allowing 100%. Then the container build template. Over here, I've given it a name, which is the template ID. I've used the container group ID, which we just created. The allocation type would be sales, because we are going to use sales order for the scenario, or the wave step code to link it to the wave. And this is the new option, optimized 3D packing added by this new feature. Earlier, we only used to have these two options. So I will keep it on the legacy just to first see the problem, and then we will see how the new feature works. So this is the simple setup. And you need to remember to connect it to the wave, so we can take a look at the wave template. So I have added the containerization step. Okay, now we have seen the setups for the containerization. Let's take a look at the product by going through the release product. And I have created an item 3D part. And over here, if we scroll down, we should not look at the manage inventory tab dimensions. They are not used for the warehouse management calculation. So we need to set up to the dimension set up at the physical dimension group ID. So this is important. And here you can see I've added the width, the depth, and the height and the volume for one piece of this item, which is a 3D part to simulate the demo with these dimensions. Okay, this is important. You need to do it for each and every item for which you wish to use containerization. Once this is done, now we can take a look at the sales order, which is over here. We will try and sell three pieces of this item. So the sales order number is 362. We are selling three pieces from this item. We release it to warehouse. Uh, it's not released, I believe, because it was already released earlier. So I will cancel the work. And I will also delete the load. Okay, now we are good to go. I will now release it once again. And now it's released. And then if we go to the load tab, we can see a load is created 819. And if we go to the load, we can see the container structure created by the system. We can see system using the old strategy wants us to pack in one large box all the three pieces. So that is the problem, as we have seen earlier. You cannot pack those three in one boxes. And this was the problem. System would say, now you go and pack these three pieces in one box. And when the packing used to happen, they used to physically realize that you cannot pack those three pieces in one box Now you understand the problem. Now we will see how this is fixed with the new features. So I will cancel the work, and let's refresh and delete the load. Now we will go and change the strategy. So I will go back to the container build template, edit, and now I will select the 3D optimized packaging option. We'll go back to our sales order, and the sales order number was 362. Release it once again. It's released. Now we go to the loads. We got a new load 820. If we open it, and let's see what container structure this time system is giving. Nice. This time system wants us to pack in two boxes. The first one, two pieces, and the next one pieces. You see the value. So this is exactly what is the improvement. That now it is not only looking at the volume and the weights data, it is also matching the X, Y, and Z dimension and comparing them to the box dimension to determine if they actually fit in a 3D model, yes or no. So there's a complex algorithm added by Microsoft in the backend behind this strategy, a lot of code which is doing the matching of the dimensions. I can visualize, but yes, it is a great enhancement. So that's all. I think in this video, my idea was to showcase what this feature can bring. You can do a lot more with this, which is standard containerization capabilities, but this was a very simple example. I have also explored a lot of issues with this 3D containerization issue, which I will share in the next video, my testing experience. It could be that it's a small problem because this is still in production preview, or it could also be that I'm doing something wrong. So I'm open for feedback, but I will share my findings in the next video. So thanks for watching, and continue to support and like the channel.